For lesson 6, we're going to look at one of our triangle coordinate proofs in a couple different ways. So triangle BAE has the coordinates B -4, -3, A 2, 1, and E -2, 7. Prove the triangle is isosceles. So the first thing we want to do is we want to graph it. So -4, 1, 2, 3, 4. 1, 2, 3, 4, -3. So there's A. There's B. A is 2, 1. And E is -2, 7. All right, and we'll connect our points here to make a triangle. So now it says prove that triangle BAE is isosceles, which means we have to do the distance of the three sides. And I'm going to do it out here because I got a little more space. So we got to do the side of BA. We got to do AE, and we have to do BE. All right. So if we sit here and take a couple minutes to do the distance for each of them, for BA, we are going to be 2 minus -4 squared plus 1 minus -3 squared. So that's going to give us, and actually, again, we're just comparing them, so we don't have to worry about simplifying or anything. So if we throw that at our calculator, 2 minus -4 squared plus 1 minus -3 squared gives us 52. All right, so square root 52. Again, we don't have to worry about simplifying. We're just looking to see if any of the two are the same. So there we go. We get square root 52. So AE, we're going to be big square root -2 minus 2 squared plus 7 minus 1 squared. We'll go back to our calculator here. So -2 minus 2 squared plus 7 minus 1 squared also gives us 52. So right now we have square root 52, square root of 52. So right now we have two equal sides. I'm just going to check BE here to make sure that we are not equilateral. So we're -2 minus -4 squared plus 7 minus -3 squared. So what was it? -2 minus, -2 minus -4 squared plus 7 minus -3, I believe. 7 minus -3 squared, and that's going to give me 104. So it actually gives me a much bigger number. So now remember, every time you do these formulas and you prove something, you have to write a sentence. Triangle BAE is isosceles because BA and AE have equal distances, making two congruent sides. All right, so again, when you write your explanation, you want to make sure that you are writing basically what formula you use. We use distance formula. What it showed you the two of them were the same. And then what was the property about what you were trying to prove? Isosceles triangles have two congruent sides, so we wanted to state that that's what we were looking for. Now, in the second part, to prove that triangle BAE is right, we're going to be after slopes. So BA, AE, and BE. All right, and again, you could do your y2 minus y1 over x2 minus x1 formula, but since you have the graph in front of you, you might as well just count boxes. So for BA, all right, this would be what connects BA here. So we are up 1, 2, 3, 4. Remember, rise first, run second. So 1, 2, 3, 4, 5, 6. So 4 over 6. And again, you're always going to want to simplify these, so we get 2/3. AE is here and here. So it was 1, 2, 3, 4, 5. -6 was our run, and -6 was our rise, and 4 was our run. So -6 over 4, which simplifies to -3 over 2. And then BE, our last one here, we're 1, 2, 3, 4, 5, 6, 7, 8, 9. Our rise is 10. and our run is 2. So that gives us a slope of 5. So I think we can see here our winners are right here. Those are negative reciprocal slopes forming a right angle. So triangle BAE is right because BA and AE are perpendicular because they have negative reciprocal slopes forming a right angle. All right, so you can see we did our isosceles piece through our distance formula. We did our right triangle piece using slopes. And then we got to make sure, again, just can't emphasize enough, every time you do a coordinate proof, when you finish with your work, you want to make sure you write a sentence.